Hello friends, let us start with this chapter, the square and cube. So there is one puzzle given. So Queen Ratna Manjuri, she wanted to share her fortune with her child, with her son, but she could not do it openly. So she gave us one puzzle. So her son Hoisnam and 99 relatives were invited for reading of her will. She wanted to leave everything to the son, but she knew that she could not do it directly. So she made a puzzle for them to solve. So there were some conditions. So the first person opens every locker. The second person is going to toggle every second locker and so on. So if it is closed, he'll open it. If it is open, then he'll close it. So these are the rules. So if the locker is toggled an odd number of times, it will be open. And if it is otherwise, it will be closed. The number of times the locker is toggled is the same as the number of factors of the lock number. For example, locker number 6. So what will happen? The person 1 will go and open it. Person number 2 will go and close it. Person number 3 will open it again. Person number 6 will go and close it. So the factors are 1, 2, 3 and 6. So every number has a partner factor. Okay, you can see some other examples here. Number 4, 1 into 4 and 2 into 2. Now the factors here are 1, 2 and 4. So these are odd number of factors. So likewise, you can see some numbers have even number of factors and some have odd number of factors. So what are squares? So you can see 1 into 1 is 1 square unit. 2 into 2 is 4 square unit. 3 into 3 is 9 square unit and so on. Okay. Now here you can see some decimal numbers also. 2.5 square. So that is 2.5 into 2.5. That is 6.25 and so on. Now here they have given us this table and told us to square the first 30 natural numbers. So you can fill this table by squaring the numbers. So 6 6 are 36, 7 7s are 49, 8 8s are 64 and so on. So what pattern do you notice? Share your observations. So let us go to the answers. So before the process began, Hoisnam realized that already knows the locker which are open. So find out which are the toggled numbers. So locker number 1, that will be open locker because it has odd number of factors. Locker number 3 will have even number of factors. Locker number 4 will have odd number of factors and so on. Now, does every number have even number of factors? No, that's not true. You can see the factors. For example, we have number 6. It has factor 1, 2, 3 and 6. That is even number of factor. Number 7 has 1 and 7. That is even number again. Number 9 has 1, 3 and 9. That is odd number of factors. So whichever are odd, that you have to consider. You have to look at them. So what insight do you get? So there are some numbers from 1 to 100 which have odd number of factors. These are they. So 1, 4, 9, 16, 25, 36, 49, 64. You might be knowing these are the squares of the numbers. Okay, these are perfect squares. So which locker numbers remain open is the question. So 10 lockers will be open. They will be 1, 4, 9, 16, 25, 36, 49 and so on. So which are these 5 lockers? The lockers which are toggled twice are prime numbers. Hence, the numbers are 2, 3, 5, 7 and 11. So the code is 2, 3, 5, 7 and 11. So first 30 natural numbers, you have to square them. So here is the table. You can observe the numbers carefully. Observe them. Look at the units place. So what pattern do you notice? So you will see that for all perfect squares ends with 0, 1, 4, 5, 6 and 9. None of them end with 2, 3, 7 or 8. Remember. So if a number ends with 0, 1, 4, 5, 6, 9, is it always a square? Now we cannot determine if a number is square just by looking at the digit in the units place. But yes, we can tell whether it is not a perfect square if it has 2, 3, 7, 8 at the units place. Perfectly, it's not a perfect square. Definitely. Now, which of the following numbers? Which of the following numbers have? Yeah, before that, this question, write 5 numbers such that you can determine by looking at the units place that they are not squares. So you know the trick now. So which numbers have 6 digit at the units place? So 38 square. Now 38 square, you look at the units place. In the units place, we have 8. 8 8 is 64. So the ending will be 4. So it will not be 6. That means they have asked us whether 6 is there in the units place. So answer is no. Then we have 34 square. 34 square is 4 4 is 16. We have 6 in the units place. Yes. Then 46 square. Yes. 56 square. Yes. 74 square. Yes. 82 square. No. Now look at these numbers. So 10 square is 100. 20 square is 400. 40 square is 800. So we have 2 zeros. Then we have 100 square, that is 10,000. 20 square, that is 40,000. So here, in the original number, there are 2 zeros. And after squaring, then we have 4 zeros. So if a number contains 3 zeros at the end, then what? So let's see about them. Number of zeros at the end of the square is always double the number of zeros at the end of the original number. So remember this. So if a number contains 3 zeros, then its square will have 6 zeros. Remember, double of it. So what do you notice about the number 0 at the end of the number and the number 0 at the end of its square? What will happen? Will this always happen? Yes, it will always happen. So what about the parity? The square of even number is always even and the odd number is always odd. So here they have given one formula for you to understand. So how many numbers lie between 2 consecutive perfect squares? Do you notice the pattern? So there are exactly 2n numbers between n square and n plus 1 square. Remember this formula. Between 3 square n and 4 square. So you can see that 3 square and 4 square. So 3 square is 9, 4 square is 16. So 2n numbers. So 2n means 3 to the 6 numbers are in between. You can check it for all the squares, perfect squares. Now, how many square numbers are there between 1 to 100? How many are between 100 and 1 to 200 and so on? So here they have filled us for us. You can check it. Between 1 to 100 there are 10. From 101 to 200 there are 4. And 201 to 300 there are 3 and so on. You can check for yourself. What do you have to do? You have to find the perfect squares between 200 and 1 to 300. There are only 3. So can you see the relation between the triangular numbers and the square numbers? So answer is given here. You can observe it. 1 plus 3 is 4. That is 2 square. 3 plus 6 is 9. That is 3 square. 6 plus 10 is 16. That is 4 square. And so on. So 10 plus 15 will be 25. That is 5 square. Observe the pattern. Observe the digits. Observe the circles. Now find whether 1156 and 2800 are perfect squares using prime factorization. So 1156 can be factorized as 2 into 2 and 17 into 17. So we can write it as 34 square. So look how they have shown us prime factorization. So you can write it once, make the factors, then they have a partner factor. If it is 2 times, write it 1 time. So 17 is 2 times, write it 1 time. 2 is 2 times, write it 1 time. So you'll get 34. So 2800. Again, prime factorization. Whatever comes 2 times, write it 1 time and multiply, you'll get it. And if there is no partner, then we can say that it's not a perfect square. So for 2800, there is paired factors are not there. So you can say that it's not a perfect square. Which of the following is not a perfect square? So we have to remember that if perfect square always ends with 0, 1, 4, 5, 6 and 9 in the units place. If it is not, then it's not a perfect square. Observe this and you'll get the answer. Next one, 64 square. So 64 square, what you have to do is you have to square it. Then check whether there is 4 in the last digit. So 64 square is 4 4s are 16. So 6 is the last digit. That's not there. 8 square. Again, units place. 8 8 is 64. Yes, 4 is there in the last place. Likewise, you can do the rest. Now, 125 square is 1 5 to 6 to 5. What is the value of 126 square? So you know that 126 square, you can write it as addition of 15625 plus 251. Now, how did we get 251? So you know that there are two n number square between n and n plus 1 bracket square. Okay, 2n number. So double of 125 is what? 250. Okay, so double of the number. So 126 and 127. So 126, we add 251 to it and we get the correct answer. Find the length of the side of the square whose area is 441. So area of the square is side square. So 441 meter square. So take the square root. The square root will be plus or minus 21. Now it cannot be negative. So length cannot be negative. So we take the positive number. Now find the smallest square number that is divisible by each of the number 4, 9, 10. So LCM we have to take. You know how to find the LCM. So LCM of these numbers is 180. So smallest number divisible is 180. So 180's factors are 2 into 2 into 3 into 3 into 5. So 5 has no pair. So multiply it by 5 and you will get 900. So this is the required smallest number. Now let us start with the next question. So have you understood this one? So they have asked us find the smallest square number that is divisible by each of the following. So first of all, we took the LCM. Then we took the factors. We saw that there is no partner for 5. So we multiply the resultant number with 5. Now we got a partner with 5. Now it is 900. So the required smallest square number is 900. Find the smallest number by which 9408 must be multiplied so that the product is a perfect square. Again, the same thing. You have to take the prime factors. You can see that 3 does not have any partner. Okay, 2 2s are 4, 2 2s are 4, like that you can just divide it if you know the prime factorization method. And then you find out the pairs. There is no pair for 3. The 3 is alone. So you multiply with 3 and you get a perfect square. So how many numbers lie between the squares of the following numbers? 16 and 17. So you know the rule, n square and n plus 1 bracket square. So double it. So 16 square, double it, and then 16 2s are 32. 32 numbers are in between. 99. Double of 99 is 198. So 198 numbers are in between them. So like this you have to do. So find the pattern. Okay, 1 square into 2 square into 2 square, that is 3 square. So actually it should be plus. So 1 square plus 2 square plus 2 square. So 1 square, that is 1. 2 square is 4 plus 4. 4 plus 4 is 8 plus 1, that is 9. So 3 square is also 9. So instead of cross, we have to put a plus sign. Then it will be correct. So there is a mistake here. Please correct it. Then how many tiny squares are there in the following picture? Right? Prime factorization, this tiny squares. So you can observe. Look at the first one. How many squares are there? Small, tiny one. So in the first, this line, you can see 5, 5, 5 by 5, 25. Then count how many there are. So there are number of squares in a row is 9 and squares in a column is 9. So 81 are there, which are bigger one. And the tiny ones are 5 by 5, that is 25. So multiply 25 by 81, that is 2025. So prime factorization of 2025, that is 3 raised to 4 and 5 raised to 2. That is how we can make the factors. Now complete the table. So here they have given the numbers. You have to cube them. Cube means you have to multiply by 3 times. The same number you will multiply with 3 times. Observe this. So 11 cube will be 11 into 11 into 11, 3 times. You can observe this, multiply for yourself and find the answers. So what pattern do you observe in the following? So cube of a number is at least last digit is 1 and ends with 1. So cube of a number ending 2 has a last digit 8. So same way you can see if it is 3, then it will be last digit 7. When cube the number ending with 4, 5, 6, 9 and 0 have the same units digit. So we know that 0, 1, 4, 5, 6, 9 are the only last digits possible for squares. What are the possible last for cubes? So last digit of cube can be any digit from 0 to 9. So similar to squares, can you find the number of cubes? 1 digit, 2 digit, 3 digit. What do you observe? So 1 cube is 8. 1 digit cube, that is 2 cube is 8. Then 2 cubes, that is 1 and 8. There are mistakes here. You can see 1 cube is 1 only. They have written 8 here. Then 2 cube, that is 2 digit cube, that is 3 cube, that is 27. 3 digit cubes, 5 cube is 125 and so on. So the number of perfect cubes increases as the number get larger and larger. So unlike squares, the cube grow more quickly. So fewer cubes fit into smaller range. So can cube end with exactly 2 zeros? No, it cannot end with 2 zeros because cube of any number, if we add zeros in the end, it will be 3, multiples of 3. So it can't end with 2 zeros. So the next two taxi cab numbers after 1729 and 4104 are and 13832. Find the ones which are positive cubes. Now here you can see next two taxi cab number after 1729 and 4104 and 13832. Find two ways in which each of these can be expressed as a sum of two positive cubes. So 2 cube plus 16 cube, that is 4104. 9 cube plus 15 cube, that is 729 plus 3375, that is 4104. Now how will you get it? You have to try different numbers. Without trying, you will not understand this. Try different numbers and then you'll see. Can you tell what is the sum without doing the calculation? Now look at these consecutive odd numbers. So their sum is 10 cube, that is 1000. Remember this trick. If there are 10 consecutive odd numbers, then we can just write that sum as 10 cube. Find the cube root of these numbers. Prime factorization method. So 64 is there. Find the prime factors, group them in group of 3, and whatever comes 3 times, write it 1 time. So 2 into 2, that is 4 cube. So cube root of 64 is 4. Then 5 and 2 is 8. Do you know how to do it? By prime factorization. You have to keep on dividing with the prime numbers. So first prime number is 2. Divide 512 by 2. Then again divide it, whatever remains. Keep on dividing till you get the final answer. So like this, you will do it for 729. Now find the cube roots of 27,000. Prime factorization method, you can do it. Then what numbers will you multiply? 1328 become a cube number. So prime factorization will be 3 into 3 into 3 into 7 into 7. So there is no triplet for 7. So they need to be in a group of 3. So 7 should be multiplied in the number. So you multiply it and you get the number which is required. Now next, straight true or false, you can just have a look at it. It's easy for you. Answers are here. Observe them. Explanation is also given. Please observe. Now you are told that you are told that 1331 is a perfect square. So can you guess without factorization but what cube root it is? So similar guess for this. So cube root of 1331 can be guessed without factorization, because we know that 10 cube is 1000 and 20 cube is 8000. So it is in between 10 cube and 20 cube. It is near 10 cube. 1000 and 1331 are very near to each other. So it can be 11. So 11 into 11 into 11. We just do it, the multiplication, and check. Then we have 4913. Again, the same trick you have to use. So 4913 is between 10 cube and 20 cube. So the number